Hello everyone, today's topic is optical packet switched networks. So this basically is the pictorial representation of a optical packet switched network in which where you can see there are multiple packets and there is a computer or the system involved. About this I'll be explaining a bit more today, so you can see this. So what basically is a packet switched network? A packet switched network is in short called as PSN. It is a type of a computer communication network that groups and sends the data in the form of small packets. This will enable the sending of the data or the network packets between the source and the destination node over a network channel that is shared between multiple users or the applications. So in the picture when I was showing, there were multiple users, there were multiple computers. Between them the data was being shared as the packets. So next is, what is the difference between packet switched and circuit switched networks, or what basically they are? A packet switched network moves the data in separate small blocks, we call them as packets, and based on the destination address in each packet, and when received the packets are reassembled in the proper sequence to make up a message. But then a circuit switched network require the dedicated point-to-point communication during the calls. Now I'll show you what basically it looks like. So in the picture you can clearly see that this is the packet switched network format. This particular format has got the guard bands, which has got a header label, a payload, and it has got certain duration in it. So let me explain about this a bit more now. So consider this particular picture. So in an optical packet switched network, that is OPS, data is transported entirely in the optical domain without the intermediate optoelectrical conversions. So an optical packet switch performs the four basic operations, that is routing, forwarding, switching and buffering. So totally how many? There are four. They are, the first one is routing. So first one is considered as routing. The first one is routing, and the next one is forwarding. After that, switching, and then the last one is buffering. So totally four operations or functions. First one is routing, second is forwarding, third is switching, and the last one is buffering. So out of which, first let me speak about the routing. So the routing function provides the network a connectivity information. So often this is about the pre-located routing table. So whereas the forwarding defines the output for each packet which is incoming. This is defined by the forwarding process, while buffering provides the data storage for the packets to resolve any connection related problems which may occur during the packet transmission. So about this, if we have understood, let's now move forward in understanding the packet network format or the network format for the packet switch network. So in this picture when you are seeing, you'll understand that this picture is about the overall structure of a typical packet. This contains a header. You can see that there is a header here. You can see a header format or a label. So, and it has got a payload. Payload is nothing but data. Payload is a data. It has got a typical header, and it requires a guard band to ensure that the data is not overwritten. If you want the privacy, you are supposed to use a guard band. So the label points to the entry of the lookup table that specifies where the packet should be forwarded. So here you have got a header or the label. This label will be having the destination address where it has to be sending the data. So such a labeling technique is much faster than the traditional routing method in which the data was being sent initially. So this packet format is all about the information about the data, because payload is all about the data. The data is connected with a label. That label is about the destination where the packet has to be transmitted. So that header or the label will be under the standard low bitrate and format, and then for the payload or the data it will be bitrate and format mutually agreed between the source and the destination edge routers. So how much is the capacity of the end router or the destination, and the same capacity has to be in the source as well, or whatever is the capacity of the source, the same has to be of the destination. So in order to have the in order to ensure that the data is not overwritten, you are supposed to use the guard bands. So a packet basically will be of 3 entities. First one is the header, second is the guard band, and third is the payload. So here the next thing is, since the labels define the routing criteria, it is important for us to consider the label switching. This will include several functions which are involved in the labeling technique, such as assignment. Assignment is nothing but writing. Recognition, that is about the readings. Swapping, which means exchanging, and forwarding. So basically 4 things can be done using a label. First is assignment or writing, second is recognition or reading, third is swapping or exchanging, and the last one is forwarding. So if this particular thing is clear to you all, I want to show you all how a optical packet switched network looks like. So in this picture, when you are seeing, you are able to find it in different clusters. There are lots of OXCs or WANs which are connected. It even has got labels. It has got a SONET client network. It has got IP client network, and here the packets in a OPS network can carry different types of traffic. Therefore, such an optical packet switching scheme can integrate existing SONET and IP based networks. So in this picture, when you consider, it is all about, it is considered using the long haul or core network connected to both a SONET and an IP network. So here the edge routers perform the functions of attaching and detaching a label. So here you can see the labels. For these labels you can attach and you can detach. So whenever there is a attaching or detaching of a label considered, it is done with the help of edge routers. So the next thing is, within the OPS network, however, the core router only processes the label, where the content of the payload still remains the same. So only alteration what is done is of the label but not of the data. This routing function typically involves the following 4 steps. That is, the first one is, you will first extract the label from the packet. So once you extract the label from the packet, you understand that the destination is very clear to you. Second one is, you will process the label to obtain the routing information. So whenever you consider the processing, this is about extracting of the destination information. Third one is routing of the payload and contention resolution if necessary. So whenever you are routing the payload, means you are transferring the payload, you will try to use the contention resolution. So if at all it is not matching the size prescribed, then you are supposed to make it in that particular way. Next is, the last one is rewriting of the label and recombining it with the payload. So if at all you have detached the label, you are supposed to reattach it. That is, you are rewriting the label and recombining it with the payload. So the first one is extraction of the label from the packets, which means you are removing it. Second is, you are processing the label to obtain the routing information. Third one is, you are finding the routing of the payload and contention resolution, and the last one is, you are rewriting of the label and then you are recombining the same with the payload. So when the OPS network, whenever you consider some OPS network that is implemented and the only label is processed electronically for the routing purposes. So here OLS stands for the optical label switched network. So if this question comes in exam, you are supposed to understand that you will be first writing that an optical packet switched network is transported entirely in the optical domain without any intermediate optoelectrical conversions. So here there will be optical packets which will be majorly doing 4 functions. The first one is routing, second is forwarding, next is switching, and the last one is buffering. So about this you are supposed to say, that is, the first routing function provides the network connectivity information. Next is you will consider the forwarding information. The forwarding defines the output for each incoming packet. Next is switching. The switching directs each packet to the correct output, while the buffering provides the data storage for the packets to resolve any contention problems which may occur during the packet transmission. So this is about the topic optical packet switched networks.